Welcome to my class of computer graphics. Today we will learn about scaling. Today we will learn about scaling. Scaling is another two-dimensional transformation. So if we look into the definition of scaling, scaling transformation alters the size of the object. So whenever we want to make a change in the size of object, we will scale the object. That means if we want to increase the size of the object or decrease it, then what we will do, we will say that we are going to scale the object. So that is the purpose of scaling. Okay. Now, in the scaling process, we either if we want to write, then how we will write that in the scaling process, what we do in scaling process, there are two things. What are those two things? One is to compress the size of the object, and next is to expand the dimension of object. So these the scaling is done, or scaling is performed in generally these two types of operation, or scaling is used for these two type of operation. Scaling operation can be achieved by multiplying each vertex coordinate is x comma y of the polygon by scaling factor. There's a scaling factor. What is the scaling factor? It is called Sx. That is the scaling factor. Sx, here Sx is known as the scaling factor. Okay. So this is called the scaling factor. And similarly, scaling factor Sx and Sy, Sx and Sy, one is for x-axis and another is for y-axis. Since we are talking about two-dimensional presentation, so we will talk about Sx and Sy. These are scaling factors. To produce the transform coordinate, what are the earlier the vertex coordinate was termed as xy. Now transformed, now how the transformed coordinate look? The transformed coordinate will be termed as x dash or x1, it's called x dash and y dash. So this is the term which is used for the coordinate x dash and y dash. This is the terminology. That is, earlier the vertex coordinate was xy, and after the transformation it becomes x dash and y dash. So this is the transformed coordinate. So we can say that x is equal to x multiplied by Sx. Wait, let me increase the font size. X into Sx. Similarly, y is equal to y into S of y. So this is the way how Sx and Sy are calculated. The scaling factor Sx and Sy scales the object in x and y direction respectively. That means Sx scales the object in x direction and Sy scales the object in y direction. So we can represent it in matrix form. How we will represent it in matrix form? Let us see. We will write that. Wait. How we will write? We will insert here the matrix which will consist of Sx and Sy. That we will write the functions of the matrix x dash and y dash. This is the way it will be written as x. Wait, it will be written as x dash. Similarly, here also we will represent as y. Wait, it is represented as x1 and here it is represented as y1. This is x dash y dash. In this way, the matrices are represented. So this is the representation of matrix, and if we, let me write the whole equation. The whole equation will look like x dash y dash, and similarly there will be we will write as x dash y dash, and then similarly we will write Sx, then 0, if we insert the in matrix form, how it will look. Wait. It will write, let me write the Sx part, and then let me write the Sy part. This is Sx and this is Sy part, and both the matrices are 0 and 0. Similarly, this will be multiplied by another identity matrix. We call it identity matrix, where 1 will be deleted and it will be known as X, and then this is Y. So this is X and Y. So this is the representation of scaling matrix. This is how the scaling is represented. Now, or we can say that it look like P1 is equal to S dot P. P1 is equal to S dot P, where that means the projected one, the scaled one will look like this. This shows the scaling process. Now, if we want to look into the diagram of the scaling process, how it will look, wait. So we will look, we'll draw the X and Y coordinate. Suppose this is X coordinate, and then we will again go to the shape and we represent it as Y coordinate. Suppose this one, then we insert the shape. Suppose this was the shape of the object which I want to scale. So after performing the operation of scaling, how the object will look. It will look as wait. Let me draw the y-axis. If we draw the y-axis and if we insert the shape, then the shape maybe after scaling, it will go to this place. So this is the concept of scaling. If the scaling factor S is less than 1, then we reduce the size of the object. If the scaling factor S is greater than 1, then we increase the size of the object. So this is the concept of scaling. Now, if we want to write the algorithm about the scaling process, how we will write the algorithm about scaling process? Let me write the algorithm. So, first step is make a 2 cross 2 scaling matrix S as how the S will look. S will look as X 0, then S, then 0 S Y. So this is how the scaling matrix will appear, Sx and S0. Now, this is the representation of scaling matrix. Now, let me write second point. That is second point. For this was the first step of the algorithm. For each point of the polygon, for each point of the polygon, that means since we are rotating the polygon, so each point will look like make a 2 cross 1 matrix P, where P 0 to x coordinate of the point and P equals to y coordinate and P equals to y coordinate of the point. This is the first sub step of the second step. Now what we need to do, we need to multiply the scaling matrix with the P matrix. So we will write as multiply scaling matrix, multiply scaling matrix S with P0 with P00 matrix P to get with P00 matrix to obtain the new transformed coordinate. So this is the major two steps of the algorithm. The next step will be draw the polygon using new coordinates. So we have drawn the polygon using the new coordinate which we obtained by multiplying the scaling matrix with P00 matrix. We have now obtained the transformation matrix, or the matrix which is used for scaling. Then after that we will draw the polygon with the new coordinates of the system. So that means the polygon shape, the polygon is already scaling or already scaled with new position, with new x and y position. Okay, so this is the concept of scaling. Now the question arises that why we use scaling. So scaling factor, actually it depends on the scaling factor that decides that whether the object can be reduced or not. In entertainment industry, where we are seeing different kind of cartoon films are popular, so here it is very necessary to understand that one object, how much it can be scaled, whether its dimension can be increased or not, or whether it can be reduced or not. So we can describe scaling as, scaling technique is a method of placing respondents in contribution of gradual changes in pre-assigned values, symbols, or numbers based on the features of a particular object as per the defined rules. So all the scaling techniques are based on the four pillars. What are those four pillars? They are order, description, distance, and scaling. So this is the concept of two-dimensional representation. Okay, so in this way, scaling occurs or scaling process is carried out. Now, soon we will learn about, in the next class, we will learn about the other 2D transformation techniques. Soon we will learn about the other transformation. Since in two-dimensional transformation, there are different types of transformation specified. We have convert the first one, translation, then we have completed with the next one. Now, after this class, all of you must note down the assignment. First assignment is define scaling. Next one is write down the algorithm used in scaling. Third one is scaling is scaling can be applied for a three-dimensional object or not. That means whether the scaling can be applied for a three-dimensional object or it is applied with two-dimensional objects only. So that is all for now. Next class, we will continue with some more concepts related to scaling.